Hello everybody and welcome back. About a year ago or so, I published these plans for my CNC controllers, which are called UCNC controller, and there are a few of them, and this is the plan for the compact version, which is, I think, the most useful of them all. They basically do the same thing, but this is sort of a Swiss Army knife for all sorts of projects. And it's really simple. It just consists of an Arduino, the Nano, two chips that control unipolar steppers, power supply, and a lot of headers for example, driving a laser output or a spindle motor, outputs for a servo, controlling outputs for a motor, stuff like that. Also it had some inputs like for a limit switch or for sensors that could, for example, do bed leveling. So it was a really simple board, but it did have the problem that it only ran with my own firmware, which, although it works really well, it is not compatible with the family of controller programs for PCs and Macs and Linux that rely on the Grbl command set. So you would have to switch off a lot of stuff to get it working. And over the past year or so, I was wondering if I should extend my G-code so it would be more like Grbl, but on the other hand, it didn't have to because it was already working pretty well, and I didn't want to put all those extensions in there because then I would just be copying what Grbl was there for and what Grbl would already do really well. So some people said I should port Grbl to the board, and a few people offered to do it, but actually none of them ever came back to me, so I figured it must be really hard because Grbl basically takes all the memory of an Arduino Nano, and it's really hard to incorporate things like an extra timer for a servo or another way of really controlling unipolar steppers without breaking all the beautiful things in Grbl, because it is very, very complicated and it is very, very sensitive to changes in timing, and it's really great software. And I didn't want to go in there and butcher it and turn it into something that just worked with this, but that, in my opinion, didn't look good. So, well, nothing happened for quite a while, and I was thinking about it about 2 weeks ago, and I thought, well, let's just try again. And what I did was I took everything that was Grbl, I left it the way it is, and I basically wrote an emulation for the stepper part that is using the unipolar drivers. So all the Grbl code would remain the same, but it would think it was driving a virtual stepper, and that virtual stepper then goes into code that moves the real steppers. The beauty of that is I don't have to change any of the timing, and I don't have to change any of the internal code of Grbl. I just have to add what is necessary to do the virtual stuff, and in the end I have to write what is necessary to move the steppers. And since these are all writes to the controllers, they're not really timing sensitive, and they don't change anything in there. So in the end, I ended up with code that still looked pretty cool, that didn't change any of the nature of it, and that was more like an addition to it than a modification, which I thought was really, really good. So I kept on going, and I did have an implementation for a timer controller for the servo that was using the timer 2 on the Nano, which if you don't use variable speed or variable RPM speed for the spindle controller, that one is still free. So I put that in there, and well, it just started working. And after about, I don't know, 1.5 or 2 weeks, I now have code that I can use the old controller that I already had together with the Grbl firmware. And even when I turn on the variable speed, I actually still have about 20 bytes left, but it's not working very well, so I turned the variable speed back off again. I may rework that in a slight way, I don't know yet. But right now it's turned off, so there's just turning the spindle on or off. There's no variable speed, which will lead to the port being pulsed by PWM. And for what I'm doing right now, I don't need it for most of my projects, because even if I have a laser with a dial, so I can dial in the power of the laser, so it's okay if I just turn it off and on. And when I was done with that, I went on to test it. And that's actually the board that came out of it. And this is everything there is. This is the little circuit that is available on EasyEDA. And you can still download that. And also, all the plans that I was just showing are also on EasyEDA. So this is really simple to copy. You just have to connect the controllers that sometimes come with these steppers to the I/O ports on the Arduino and flash the firmware, and this will start working. And it's really, really simple. So you could also do this with a very simple breadboard. And the plan is simple too. So what does it do? Everything was the way I originally intended it for the UCNC board. So we have the steppers, which will move in the X, Y, and Z direction. We have the servo motor, which will turn about 90 degrees in one direction if you start the spindle. That will return to 0 if you stop the spindle, and it will go into the other direction if you reverse the spindle. You can also change the angle at which it changes by changing the spindle speed. So if you have the spindle speed below 90, it will just turn about that angle. So a spindle speed of 20 will turn the servo about 20 degrees. Apart from that, nothing's changed. I have the output for a laser or for a spindle motor. This can drive about 800 milliamps to 1 amp. If you drive 1 amp, you might want to put a small heatsink onto the driver chips, but that's up to you. Just figure out what works the best. It also works with between 5 and 12 volts. You could have more than 12 volts, but then things need to change a little bit, because sometimes the Arduinos are rated for up to 20 volts of input, and sometimes they will only accept up to 12. So you need to kind of make sure that everything you have around it still works with a higher voltage. And so let's move it, and it's really simple. I'm using a Grbl controller, so it's powered up right now. So if I move the x-axis, it will turn the stepper. If I move the y-axis, once again, what did you expect? It turns the stepper. And the same is true for the z-axis. And as far as I can tell, the timings are still correct. There's no jitter on the stepper, which is really cool. I was testing this for a while, so I can just send a program now, which is a program to laser something. I don't know. I think it's a front piece or something. So if I send the code, it will just start moving the axis. This is for a plotter device, so it will not use the z-axis, but the x and y axis, and it will turn on and turn off the spindle driver to activate and deactivate the laser. At the same time, when it's activating the laser, you will see the spindle servo going up and down, so it can lift or drop a pen if it's drawing on a PCB, for example, or if it's plotting something. So yeah, it's really simple. It's easy to use, and the code is already on my GitHub. I posted a few changes today that also include the servo code, and everything in there is, I suppose, finished. If somebody wants to test it out, and if somebody does test it out and finds something, please either open an issue or put something in the comments of this video, and I'll make sure to fix that. Apart from that, it's really simple. It's so easy. It's just a lot of fun. And now I just turned off the driver and it turns it back on again. And you can just see it's working. There's not much to see here. It's just what you expect it to do. So let's turn it back off. Also, the speeds are really good. It does come unconfigured, so you still have to configure your steps per millimeter and your maximum speeds. So the code that I'm sending out does not have anything in there that would pre-configure it to some sort of machine. Because I wouldn't know which machine to pick if I was supposed to pick the small plotter or one of these slightly larger laser gantries, or I don't know. I didn't pick anything. So you're basically free to choose. If I disconnect this, I can actually move it around a bit better. So as you can see, I just stuck this on some wood, and it's really simple, but it's supposed to be this simple. This little controller board is just like, it's the Swiss Army knife of controlling steppers. I use it for my meters, for my dials. I've used it for a small gantry that can basically point a camera. I've got an I2C header on here, so it uses the usual I2C controllers on the Nano, so you can use it to talk to other stuff. So it's a really versatile board, and with the Grbl firmware now available for it, it becomes even more versatile, and I really like it a lot. I'm going to make another small CNC machine with this, and I gotta figure out how I can do a very simple Z-axis using one of these steppers, and I don't know, maybe a belt or something, and I'll think of something. I'll show it when I've got it. I think this is a lot of fun, and regarding the development, it's a whole circle now. So I developed the board because I had a controller firmware, and the board is now working very well. Then I came back to redesigning it, making it smaller, making it more versatile, and now I even have the firmware on it that was actually that was actually planned, or that was the firmware to go on one of these boards, and now it's actually working, which is really cool. And yeah, I'm just happy. I just wanted to share this, that it's working right now, and it is as simple as it can get, and it is really cheap. I mean, there's about, I don't know, $5 of parts on this board. You can get the board from Easy EDA at a super low price. The steppers are about $2 a pop, and the servo is, I don't know, what are they, like $3 right now? I don't know. And that gives you everything so you can build a small CNC for yourself. And you can have the firmware that is the one that is mostly used. It is very versatile. It is really easy to configure. So a great package. Thank you very much for watching, and for today, that's it.